In this sequence, we will look at two topics. First, we will look at the MOSFET in its full glory. So far, we looked at the MOSFET as a switch, and we also looked at its behavior as both as a short circuit, and in a slightly more detailed model, we looked at its behavior when the MOSFET is in its on state as a resistor using the SR model. We will look at the MOSFET in its more fuller form, and look at its more of an expanded behavior for the MOSFET. And then we will look at building some circuits such as the amplifier using the MOSFET. So continuing with our review, in the last sequence, we looked at dependent sources. And the way dependent sources work is that, as shown in this example, which has a dependent current source, this is a voltage-controlled current source, VCCS. And in this, the current of the dependent current source is dependent on some voltage V that is captured as part of some other portion of the circuit, and the V here could be some other voltage in the circuit. So V here is the difference between the potential difference between the A prime terminals. And so I can build a circuit containing dependent sources where their variables such as currents or voltages and so on depend on other parameters in the circuit. And we looked at a bunch of other dependent sources such as a current controlled voltage source and so on. We also looked at superposition rules with dependent sources. While there are many ways of doing this, and you can look at more details in section 3.5.1 of the textbook, a method that we will commonly use is to analyze circuits with dependent sources using superposition by simply leaving all the dependent sources in. Okay, so you just leave the dependent sources in the circuit, don't touch them, and according to the superposition method, solve for one independent source at a time. Okay, recall with the superposition method, I shut off all the sources except for one source. Okay, compute the partial result and do this for every independent source. Okay, I just leave my dependent sources in, and I just do this one at a time with independent sources, and this will take care of our dependent sources in circuits where we apply the superposition method. Then let me do a quick review of the amplifier, and the reading for this to get some more detail is chapter 7.3 to 7.7. So we looked at the amplifier in a previous sequence, and we constructed the amplifier using a voltage-controlled current source. Okay, in this case, my current ID through the dependent source was related to some voltage applied at its control port. Okay, so this was my control port, and in this case, I applied a voltage VI across the control port, and that caused the current ID to flow through the dependent source. And in the example that we covered the last time, the current ID was related to the input voltage according to ID was equal to K divided by 2, where K is some constant, times VI minus 1 all squared. And we said, for the example dependent source that we talked about, we said VI needed to be greater than 1 volt for this current source relationship to apply. Okay, so we said when VI was more than 1 volt, then the dependent source had a current given by K divided by 2, VI minus 1 whole squared. And when VI was less than 1, then the dependent source shut off. So we said that for this little circuit pattern, the output voltage V0 was given by Vs minus ID RL. Okay, Vs was a supply voltage, and the way I got that was by writing the node equations at this node with the unknown voltage V0. Okay, so you can write the node equation pretty straightforwardly as a V0 minus Vs divided by RL is the current going up, and if I sum the currents leaving the node, then I would add ID to that, and that would be 0. And then if I went ahead and simplified this, I would get V0 equals Vs minus ID RL. And then where ID here was given by the expression for the current, K divided by 2 VI minus 1 whole squared. Now, one important point here is you recall I talked about patterns in circuits and electronics. And we said that although we could build circuits many which ways, we tend to focus on a few patterns. Okay, so this pattern is a common pattern where I have a resistor connected to a supply and then connect it to a dependent source to ground, and then have some input providing a voltage. This is again a very, very common pattern that you will see a lot in this course. So before we go on to new material in this sequence, I wanted to refresh your memory on the IV relationship for a current source. So recall what the IV relationship for a current source was. For a independent current source, no matter what the voltage was, my current was a constant. So this is the IV relation for a current source. Now, we'll use this fact and observe behavior of certain devices, and when you see the current versus voltage relationship looking like this, where the current looks like a flat line, then that is indicative of a current source. So I want you to hold that thought. Hold that thought, and when I show you some flat lines, I want you to say, aha, current source. So just keep that thought, and we'll get to that in a few minutes.